somewhere out there, the universe stops being beautiful. It becomes something else entirely, something colder. A place where light gives up. A place where time forgets how to move. A place where matter is crushed into screams of radiation. These places are real, and we have found them. Not in myths, not in fiction, but in data. Telescopes have seen them, and the readings are disturbing. Tonight, we travel to the universe's most terrifying addresses. And by the end, you may wish we had not looked. Our first stop hides in the constellation Aquila. It is a star called WR104 spinning fast. It is a Wolf-Rayet star near the end of its life. When it dies, it may fire a gamma-ray burst. That burst could last only seconds, but it carries the energy of the sun's entire lifetime. Some early studies suggested its beam might point near Earth. Newer measurements lowered that fear considerably. Still, it sits roughly 8,000 light-years away, a loaded cosmic rifle slowly turning in the dark. Now drift outward, past our galaxy's quiet edge, toward a place astronomers call the Boötes Void. It is a near-empty bubble of space, around 330 million light-years wide, with almost nothing inside. Galaxies should fill it, but they do not, a silence so vast it unsettles cosmologists. Imagine standing inside that emptiness at night. No nearby stars, no familiar constellations, only distance. If our Milky Way sat at its center, we might never have known other galaxies existed. Next, picture a place where iron wanes from the sky. The planet is WASP 76b. It orbits its star in under 2 days. One side faces 2,400-degree heat forever. Iron in the air vaporizes on the hot side. Then winds carry it to the cooler night side. There, the vapor cools, condenses, and falls, drops of molten metal falling as rain. It is a real place, confirmed by spectroscopy, a world where weather itself becomes a weapon. Now turn toward the constellation Centaurus. There floats a quasar called 3C273. Its core is a supermassive black hole. It feeds on gas with monstrous efficiency. The energy released outshines entire galaxies. From 2 billion light-years away, it still glows brightly. Anything near its inner edge is doomed, torn apart, heated, and flung outward as radiation. It is a furnace older than our solar system, still burning, still hungry, still visible to us. Closer to home, something stranger waits. It is a star named V Sagittae, slowly merging. 2 stars locked in a tightening spiral dance. One feeds the other, faster every year. In a few centuries, they may collide. The result could be one of the brightest novae ever. For a brief time, it would rival Sirius, then fade, leaving a scarred remnant behind. We watch it now knowing the ending. We just do not know the exact date. Travel deeper still into a neutron star's heart. A spoonful of its matter weighs billions of tons. Its surface gravity is 200 billion times Earth's. A single sugar cube of it would crush mountains. Some neutron stars spin hundreds of times per second, beaming radiation across the cosmos like lighthouses. If one passed close to our solar system, it would not need to touch us. Its tides alone would shred the Earth long before impact. Now consider magnetars, neutron stars with monstrous fields. Their magnetism is a quadrillion times Earth's. From halfway across our galaxy, one once flickered. It briefly disturbed instruments on satellites here. If a magnetar came within 1,000 kilometers, your atoms would simply unravel. Not burn, not crush, but dissolve into wrong shapes. Chemistry itself would stop working around you. Thankfully, the nearest known magnetar is far away, far enough that we can study it safely. Drift outward again toward a known black hole. Its name is Pond 6118. It is one of the largest ever measured, roughly 66 billion times the sun's mass. Its event horizon could swallow our entire solar system, many times over with room to spare. Around it spins a disk of superheated plasma, brighter than 140 trillion suns combined. It is so distant we see its youth, a monster from when the universe was young. Now picture a planet drifting with no star. Astronomers call these rogue planets. They were flung from their solar systems long ago. Now they wander between the stars, alone. Their surfaces sit in your absolute zero darkness. No sunrise, no seasons, no warmth from above. Some may hide oceans beneath thick ice shells, heated only by their own slow internal decay. Billions of these silent worlds may roam our galaxy. We have only glimpsed a handful so far. On one such world, you would not see your hand. Starlight there is a faint, useless smear. Its atmosphere, if any, would freeze into snow, nitrogen and methane falling slowly as crystals. A wanderer like that may pass near our sun someday. Most would simply drift by, unseen and silent. If you could glimpse one of these places with your own eyes, which would it be? Tell me below. Stay with me, because the strangest place is still ahead. We have not yet reached the worst. Now turn toward galaxy NGC 1277. At its core sits an oversized black hole. It holds about 17% of that galaxy's mass, an outrageous, almost impossible fraction. Most galaxies host black holes, far smaller relative to them. This one grew in a way we cannot fully explain. It is a question wrapped in darkness, a reminder that our models still have gaps. Something there grew faster than its galaxy could. We are still trying to understand how. The early universe may have been stranger than expected. Seeds of giants forming in shadow. Next, consider Eta Carinae, only 7,500 light-years away. It is a stellar bomb on a slow timer. It already had one massive outburst in the 1840s. That eruption nearly outshone every star but the sun. The star survived, but it is profoundly unstable. One day, it will likely explode as a supernova. When it does, our night sky may briefly change. A new, blinding point of light will appear. We do not know if it will fire today or in 100,000 years. Now drift toward what astronomers call the Great Attractor, a gravitational anomaly pulling our galaxy toward it. It sits roughly 250 million light-years from us, hidden behind the dust of our own Milky Way. We feel its pull, but we cannot clearly see it. We only know something enormous is there. It is dragging thousands of galaxies inward, including ours, at hundreds of kilometers per second. You are moving toward it right now. Slowly, silently, and without any way to stop. Travel inward again to a binary star system, 2 stars orbiting in V Sagittarius' deadly embrace. Or to a pet, a triple star nest of pinwheel winds. Its dust spiral suggests a future gamma-ray burst. If aimed at Earth from close range, gamma-ray bursts could damage our ozone layer for years. Thankfully, APEP is thousands of light-years away. Its danger to us appears very low. But its very existence teaches us something. The galaxy hides many such patient threats. Now picture the edge of a supermassive black hole. The accretion disk roars near light speed. Atoms that reach temperatures of millions of degrees. They scream radiation across the electromagnetic spectrum. Anything that crosses the event horizon never returns. Not light, not signals, not information. You would not feel a boundary as you fell, but to outside observers you would freeze in time. 2 truths in the same place, somehow both real. Physics breaking quietly inside the dark. Now consider Westerhout 49 and 2, deep in our galaxy. It is a young, monstrous O-type star. Its surface burns at over 35,000 degrees. Its winds strip planets like a hurricane strips sand. It floods its neighborhood with ultraviolet light, cooking any forming worlds before they can finish. It is a star that builds nothing around it, only ruined nurseries and scattered gas. Star formation itself can be a violent affair. The universe does not gently make worlds. Travel further to a so-called blazar, like Markarian 421. Its jet points almost directly at Earth. We sit, in cosmic terms, downrange of its beam. From 400 million light-years away, it still glows brightly. If we were closer, that jet could sterilize planets. Lucky for us, distance softens its fury. Yet some blazars flicker and brighten unpredictably, reminding us the universe is rarely truly calm. Even the quiet places are only quiet for now. Now drift to the Carina Nebula, glowing colossal. Inside it, pillars of gas stretch for light years. New stars ignite within, harsh and bright. Their radiation slowly destroys the very clouds that birthed them. It is a nursery and a graveyard at once. Creation here always carries quiet violence. Now imagine the inside of a hypernova explosion, a giant star collapsing far faster than normal. It launches twin jets at nearly light speed, punching through the dying star from within. These jets can produce the brightest events known, gamma-ray bursts visible across most of the universe. For a few seconds, one star outshines billions, then it fades into a black hole silence. Somewhere tonight, in some distant galaxy, this is happening. Now drift toward HD 189733b, a deep blue world. Its color tricks you into thinking of Earth. But its skies rain sideways with molten glass. Winds tear across it at 8,000 kilometers per hour. That glass shreds anything it touches at supersonic speed. A planet painted with ground-up daggers. Beautiful from afar, lethal up close. The universe has many such cruel disguises. Real data, real spectroscopy, real horror, real wonder. Now imagine 55 Cancri E, a so-called diamond world. Its mantle may be rich in carbon under pressure. Its dayside reaches hot enough to melt iron. Lava oceans may slosh across its surface. We are uncertain about its exact composition, yet its very possibility unsettles our idea of normal. Now look at our own backyard with honest eyes. The sun itself is a controlled catastrophe. It is a slow-motion nuclear furnace burning steadily, holding its own collapse against its own fusion. In about 5 billion years, it will swell outward, likely engulfing Mercury, Venus, and possibly Earth. It is not malice, only physics following its rules. Every star ends, ours will too. We live, briefly, inside a star's safe middle chapter. Around us, the heliosphere holds back cosmic radiation, a bubble of solar wind shielding our biology. Without it, our DNA would slowly tear apart. The terrifying place out there starts at our doorstep. We simply do not feel it because our star still hums, a quiet privilege easily forgotten. Now widen the view to the universe entire, galaxies racing apart ever faster into deeper night. In the far future, stars will burn out. Black holes will slowly evaporate into nothing. Even atoms themselves may eventually decay, a cold dark forever beyond imagination. That fate is the most terrifying place of all, not a location, but a destination in time. And yet, we are here, now, looking back at it, curious creatures on a small blue world. We mapped the iron rain and the hungry voids. We measured the black holes in the screaming stars. We named the monsters instead of fleeing from them. That perhaps is the bravest thing we do. The universe is not cruel. It is simply vast and indifferent and astonishing. These terrifying places are not threats whispered in the dark. They are pages of a story we are still reading. If this journey moved something in you, share your thoughts below. Subscribe and ring the bell for more journeys into the cosmos. Out there, the dark is full of monsters and full of light.